Now we're going to use Biot-Savart Law to get the answer to the same question, that is the magnetic field around the current carrying wire. So let's just do it for outside the wire using Biot-Savart Law. Now, Biot-Savart Law says that the magnetic field dH due to a current element is I over 4 pi dl cross r hat over r square. So this dl is a length element. It's a vector. Its direction is defined in the direction of the current. R hat is the unit vector from the current element to the point of interest. R is the distance between the current element and the point of interest. So here we have the current I flowing in the wire. We are interested in the magnetic field at point P dH due to this current element, and then we will integrate over all current elements to get the answer. So you can see that the angle between the dl vector and r hat vector here is, if I call the angle between r and a to be x, will be equal to 90 degrees plus x. So this is pi over 2 minus x here. I have a right triangle, that's the blue one, and the red one should be x because the total should be pi. So I have a total angle between delta L vector and r hat vector to be pi over 2 plus x. Okay, so the magnetic field dH will be I over 4 pi in magnitude dl. The magnitude of r hat is 1. The magnitude of the dl vector is dl. And the angle between them is x plus pi over 2. So it's going to be sine of x plus pi over 2 because it's a cross product divided by r squared. Now, what is sine of x plus pi over 2? So let's think about this. Sine of x plus pi over 2 is sine x cosine pi over 2 plus cosine x sine pi over 2. This is 0 here, so that's 0, and here this is 1. Therefore, sine of x plus pi over 2 is cosine x. All right. So we have the magnetic field due to this current element equals to I over 4 pi dl cosine x divided by r squared. Now I called the distance between the wire and the point of interest P to be A here. So if you look at this right triangle, the cosine of x, r times cosine of x, is equal to a. So instead of r, which is the radial distance between the current element and the point P, I can use a divided by cosine x. So substituting that into the Biot-Savart law, the magnetic field due to this current element should be I over 4 pi dl cosine x divided by a over cosine x squared. So this will give me I over 4 pi dl cosine cube x divided by a squared. Now, if you concentrate on this little triangle here, we see that when you change the angle x by an amount delta x, we're going on an arc, so this arc length will be equal to r times delta x. So it's like r times delta theta in when you go through an arc length in a circle. So this is r times delta x is our arc length, and so from this triangle we can see a relationship between dl and r delta x and the angle x. So from this triangle I can see that dl cosine x must be equal to r times delta x. So when you make this small angular displacement, we assume that the angle here is also 90 degrees, approximately 90 degrees. So it's a very small angular displacement. So with that we will have delta L cosine x equal to r times delta x. So we can write for dl r times delta x divided by cosine x. So basically what I'm calling here delta L is dl, it's the same thing. Alright, so with that, Biot-Savart law will give me I over 4 pi. For dl I write r delta x over cosine x. So here I write r delta x over cosine x will give me cosine square x divided by a square. And then I also have r is a over cosine x, so this will be I over 4 pi. If I substitute a over cosine x here, I will be left with delta x cosine x in the numerator, and this will become a, and not a square, because one of the a's will cancel. Now basically everything is written in terms of x. So the total magnetic field H will be then this integral I over 4 pi a integral over x, where x goes from minus pi over 2, assuming an infinitely long wire, cosine x delta x. So if I perform this integral, so I will find that h is equal to I over 4 pi a integral from minus pi over 2 to plus pi over 2 cosine x delta x, that is I over 4 pi a. The integral of cosine is sine, sine x evaluated between minus pi over 2 and plus pi over 2. So this will give me I over 4 pi a sine of pi over 2 minus sine of minus pi over 2. So this will become the magnetic field. Sine pi over 2 is 1, sine of minus pi over 2 is minus 1, 1 minus minus 1 becomes 2, I over 4 pi a times 2, so this is going to give me a 2 here. Therefore the magnetic field at position P at a radial distance a is I over 2 pi a. So this is the same answer we have found using Ampere's law. So if you go back to Ampere's law, for r greater than capital R outside the wire, the magnetic field is I over 2 pi r. Once again, this is in SI units. So we have used Biot-Savart law in SI units. Okay, so this was just a reminder of how to use Biot-Savart law. So what we did is we considered a current element which has a length dl multiplied by the current. It's defined as a vector that is in the direction of the current. The magnetic field due to this current element is I divided by 4 pi dl cross r hat over r square. So let me just remind you here, if you have the more familiar form from your basic physics classes, this is actually mu 0 I over 4 pi dl cross r hat over r square for the b vector. But we're talking about the h vector here, so b is equal to mu 0 h. We're assuming we're doing this in vacuum. Okay. So the angle between dl and r hat is x plus pi over 2. So x I call the angle between r and a, 90 degrees, so pi over 2 minus x on the other side of this triangle. And since I have, I'm basically considering a small variation in x to be delta x and a tangential to this variation, an arc length r delta x, I'm going to have 90 degrees plus 90 minus x, 180 minus x, so x should be the red region that I have labeled between delta L and the perpendicular that I have drawn. So here from this triangle I see dl cosine x is r delta x. R delta x is arc length. So it is basically assuming that you are going through a circular region, so you have a radius r, angle delta x, then this length s is r delta x. So that's what we're doing here. Okay, and for sine of x plus pi over 2, using the expansion of sine of x plus pi over 2, or sine of a plus, please, sine a cosine b plus cosine a sine b, we show that it is cosine x. And for r cosine x, from this right triangle here, LRA, well, not L, L is the total length, but it's RA, R is the hypotenuse of this triangle. We see that r cosine x must be equal to a. So for r, we can substitute a over cosine x. And for dl, we can substitute r delta x over cosine x. Doing these substitutions and integrating over x from minus pi over 2 to plus pi over 2, so that we will be spanning, so this minus pi over 2 plus pi over 2 implies infinitely long line here. So we see that if we perform this integral, we obtain the identical result when we used the Ampere's law, and this is again the result that we obtain using SI units.